So let's look at the following questions as a pre-guide against any future examination you may have under quantitative methods. Question number 1. Given that 102x multiplying 3201 and that is equal to 3263. Find x. How do we find x? So here, let me have my solution here. We have what? 1, 0, 2, and x as a matrix multiplying 3, 2, 0, 1. And that is equal to 3, 2, 6, 3. So how do you solve for x? So here, we say that the first row of the first matrix will multiply the first column of the second matrix. Then the same row will multiply the second column of the second matrix. That's going to result to addition. So this is what we mean. We will have what? 1 multiplying 3 plus 0 multiplying 0. Okay, that is the addition part. Then it's going to result to the first entry of the result. And then the same row will then multiply what? The second column of the second matrix. So that one too, we have 1 multiplying 2 plus 0 multiplying 1. 0 multiplying 1 like this. Okay. And then once you are done, we also come back to the second row of the first matrix and we follow the same logic of the multiplication. So we have 2. So we have 2 multiplying 3 plus x multiplying what? Multiplying 0. Then we have the last entry. We have 2 multiplying 2, these 2 multiplying these 2, and then x multiplying what? 1. So that will result to plus x multiplying 1. Okay. And that should be equal to 3, 2, 6, 3. So once you get to this stage, you just do what we call a corresponding entries, right? So we'll compare the entries of x against its corresponding what entry in this matrix, all right? So here, since we are interested in finding x, we'll just take into account 2 multiplying 2 plus x multiplying 1. And that should be equal to what? 3, right? So we have 3 here. So therefore, we have x to be equal to 3. 2 multiplying to going to result to 4. So 4, when it joins the 3, becomes what? Negative 4. And so therefore, we are getting x to be equal to what? Negative 1. And that's going to give us option D. Then you are done. So that is how we go by that. Let's move on to question number 2. Given that A is equal to 4, 1, 2, 3, and B is equal to 1, negative 2, negative 1, 4. Find 2A plus 3B. So it is also a scalar multiplication of a matrix. So we have 2A plus 3B. And that should be equal to, so we multiply 2 by the matrix 4, 1, 2, and 3. Then you say plus 3 multiplying the matrix 1, negative 2, negative 1, 4. So what are we getting? 2 multiplying 4. So here, each scalar will multiply each element in the matrix, all right? So 2 multiplying 4, we are getting what? 8. 2 multiplying 1, we are getting 2. 2 multiplying 4, 2 multiplying 2, we are getting 4. And then 2 multiplying 3, we are getting 6. So that's going to be the first result of the scalar multiplication of 2 by matrix A. Then 3 also follow the same logic. 3 multiplying 1, we are getting 3. 3 multiplying 2, we are getting what? Negative 6. 3 multiplying negative 1, we are getting negative 3. 3 multiplying 4, we are getting 12. So once you're able to get to this state, here you deal with what? Adding corresponding what? Entries. Okay, so we'll add 8 plus 3. What are we getting? We are getting 11. We'll add 2 plus negative 6. We are getting what? Negative 4. We'll add 4 plus negative 3. We are getting what? Positive 1. And we'll add 6 plus 12. We are getting what? 18. And we're going to get the result to be 11, -4, 1, 18. And that's going to what? Which of these options will meet it? And that should be option A. Question number 3. Find the values of x and y which satisfy the equation. So we have this equation. So we have 5x, 4, and then -1, all multiplying a 2 by 1 matrix, which is 2, y, and all is equal to what? 4, 5. So we are asked to find the values of x and y. How do you go by finding the values of x and y from this equation? This is what you're going to do. You use the same rule for matrix multiplication so that you get the result, right? So here too, we will say that the first row of the first matrix will multiply the first column in this matrix. After that, the second row also multiply in that line. Okay, so we're going to have 5 multiplying 2. What are we getting? So that's going to be 5 multiplying 2, and then x will also multiply what? Y. That's going to result to addition. So we have x multiplying y. Okay, so that's going to be the first part, because here in this matrix we have only what? 1 column. All right, 1 column and 2 rows. Okay, so once you are done with the 5 and x on the first row of the first matrix, we come back to the second row of the first matrix and also do same here. So here to 4 will multiply what? 2. So that's going to be 4 multiplying 2. Then -1 will multiply what? -y. So that's going to be plus -1 multiplying y. And at the end of the day, what are we going to get? So we're going to have here to be equal to 4 and then 5. Okay, so once you're able to get this, they therefore tell us that you should have, let me create a space here. So 5 multiplying 2, you are getting 10. Okay, x multiplying y, you are getting xy. And that should be equal to, okay, let's also have this. We also have 8. Then here should be what? -1 multiplying y should get fetch as -y. Okay, and that should be equal to 4 and then 5. So here, once you are getting this, we deal with the corresponding entry. So this is just a 2 by 1 matrix, 2 rows, 1 column. So we compare 10 plus xy to 4, and then 8 minus y to what? 5, 2. So this is what you're going to have. We have 10 plus xy to be equal to 4. That should give us equation 1. And we have 8 minus y to be equal to 5. And that should give us equation 2. Okay, so here you can solve for what? Y. So we therefore say that we can have 8 here and then send 5 here, making it what? Negative. And then the y will join after the equal sign, and that should be what? Positive. Okay, so the 5 will join the 8, making it what? Negative here. And then the y also join after the equal to sign. That makes it what? Positive. So we are getting y to be equal to what? 3. So once you're able to get y to be equal to 3, then we will say that at y to be equal to 3 from equation 1, we can solve for x, right? So that should be what? 10 plus 3x, and that should be equal to 4. So we have 3x to be equal to 4 minus what? 10. So we have 3x to be equal to what? 3x to be equal to -6. So we divide both sides by 3. What are we getting for x? X should be equal to what? -2. So here we have x to be equal to -2, then y to be equal to what? 3. So among these options, you should clearly see that x is equal to -2, and then y is equal to 3. And that should be option what? D. That should be option D in that line. So let's take note of that. Question number 4. What is the inverse of A? What is the inverse of A? Which is equal to 1, 2, 3, and then 4. So you're asked to find the inverse of A. So to find an inverse of a matrix, this is what we do. An inverse of a matrix, say A with what? Exponent -1. That is what we represent as an inverse. Should always be equal to 1 over the determinant of what? The matrix, okay, and then multiply by D and A, then negative C, negative B. What do you mean by negative C, negative B, and then D and A interchanging? You realize that in our normal matrix, if I have matrix, A should be equal to, let's say, A and B, C and D. Okay, to find the determinant of this, we'll say that it should be what? The product of the downward diagonal. Compare that to the product of what? The upward what? Diagonal, right? So we have what? That A to be equal to AD minus BC. So once you're able to know the determinant of the matrix, you just find what? That for you to deal with an inverse, it should be 1 over the determinant, say AD minus BC, and then multiply by, when we come to the matrix itself, all that we want to do when it comes to inverse is to interchange A and B position. So D will take A and A will take D. And then we negate what? The C and then B. So that becomes negative C, that becomes negative B. That's why we're getting this formula for the inverse of a matrix. And I believe that is clear. So that's what we are talking about. That's what we want to know when it comes to inverse of a matrix. That's what we want to follow to find the inverse of the matrix. So let's take note of that. So now let's find the determinant of 1, 2, 3, 4. So we'll say that A should be equal to 1 multiplying 4 minus 3 multiplying 2. What are we getting? We have here to be 4. We have here to be 6. So that should be negative 2. So once you are getting negative 2, that is perfect. Therefore, we'll say that A inverse should be equal to 1 over what? Negative 2 multiplying the interchanging position of what? 1 and 4. That should be 4 and what? 1. And we negate 3 and negative 2. So that becomes negative 3, negative 2. Okay. So what are we getting? We have, so here becomes what? A scalar multiplication of what? A matrix. So negative 1 over 2 will multiply going to multiply each entry in the matrix, right? So we're going to have here to be what? Negative 1 over 2 multiplying 4. We're going to fetch us negative 1 over 2 multiplying 4. We are going to get what? Negative 2. Negative 1 over 2 multiplying negative 2. We are going to get a positive 1. Negative 1 over 2 multiplying negative 3. We are going to fetch us what? Positive 3 over 2. And then lastly, negative 1 over 2 multiplying 1 should fetch us what? Negative 1 over 2. So therefore, the inverse of matrix 1, 2, 3, 4 should be equal to negative 2, 1, 3 over 2, negative 1 over 2. And among these options, the best option to go for should be option what? B. And I hope that is correct too. Yeah, so B. Go for that. Question number 5. Find the values of x plus y if 3, 2, 2 and 3 multiplying xy is equal to what? 1, 4. So we have 3, 2, 2 and 3, xy is equal to what? 1 over 4. So how do you find the values of x and y? So this is what we're going to do. 3 will multiply x. What are we getting? So we have what? 3 multiplying x plus, then 2 will multiply what? Y. So you have what? 2 multiplying y. So that's going to be the first entry of the result, right? And then we come to the second row of the first matrix, multiplying the first column of the second matrix. So that's going to give us what? 2x plus 3y. Okay, so what are we getting? That should be equal to 1, 4. So once you're able to get this, then we'll say that we want to compare corresponding entries. So we'll have what? 3x plus 2y, and that should be equal to 1 as equation 1. And then we have 2x plus 3y, and that should be equal to what? 4 as equation 2. When you get to this, we can easily use a calculator to solve for this equation. So this is how we go by using a calculator. So on your calculator, you just locate mode on your calculator. Okay, with my case, it's going to be a different section altogether. But for your case, you locate mode on your calculator, you go to 5, and you select an equation of this form. Equation of this form, ax plus by is equal to what? C. That's what That's what you should select. So you go to mode, you go to 5, and you select this equation. Ax plus by is equal to C. Okay. So once you're able to get that, you get, or you find on your calculator, the screen of your calculator to appear like what you see here in my case. All right. So therefore, we'll start with equation 1. So the Ax, by, and c are actually, the a and b and c are actually their coefficients. Okay. So when you take the x, the coefficient is what? Is 3 in this case. Right. So we just type in 3 and press equal to sign. And we go to y, we press 2. And then we go to c, press 1. So that is the first part. Then second part 2, we have what? 2. Okay. And 3 for the y. And then 4 for the c. So once you are done with the entries, you just press equal to sign. And you get your first value of x to be equal to -1. And then what will be for y? Then y2 is also equal to what? Y is also equal to what? 2. So this is how we use the calculator to solve for an equation, to solve for a simultaneous equation. I mean, equation involving what? 2 variables. So let's take note of that. So once you're able to get x to be equal to 1 and y is equal to, therefore we'll say that x plus y should be equal to -1 plus 2. And what are we getting? Should fetch us what? Positive what? 1. So among these options, the best answer to go should be what? Option B. And you are good to go. So let's take note of that. Let's move on to question number 6. Find the value of x in the equation. So we have -2, 2, 1, 1, 1, 3, 1, x, and then -1. And all is equal to 16. So here, all that is trying to tell us that you need to find the determinant of what? This matrix. And once you find the determinant of this matrix, it should be equal to what? 16. So let's see how you find the determinant of a matrix using the arrows approach. So per the arrows approach, this is what you're going to do. You must first of all have the original matrix. So you have what? -2, you have 2, you have 1 here, we have 1, 1, 3, and we also have 1, x, -1. So in using the arrows approach, all that you want to do is to repeat what? The first 2 columns of the original matrix given in question. So you're going to repeat this and repeat this as part of the original what? Matrix given in question. And I believe that is clear. So here, you're going to have here to be what? -2, 1, 1. And also repeat this. We have what? 2, 1, and then x. So you have this as a new matrix. So once you're able to do this, then this is what you're going to do. Wherever you see 3 lines or 3 numbers that forms what? A diagonal section, you just draw or to indicate that. So this is what we're going to do. We will start by indicating the downward what? Diagonals, and after that we'll move on to the upward what? Diagonal. So I can clearly see that I have -2, 1, and 1 forming a diagonal line, so I can have a line to indicate that. Okay, so this is going to my first what? Diagonal line, and then 2, 3, and 1, 2 is also forming that line too. So I'll have this. And lastly, we have 1, 1, and then x. So that one's also forming an arrow. So once you are done, we move on to the upward one. So the upward ones too, I can see that we have 1, 1, and 1 here. So that's also forming an upward arrow. We also have x, 3, and -2. And we also have -1, 1, and 2, also forming an upward diagonal arrow. Okay, so once we are done with it, this is what we want to do. We'll find what? The sum of the product of the downward what? Diagonals, and then compare that to the sum of the upward what? Diagonals. The sum of the product of the upward diagonals. After that, we equate that to what? 16. Because we said when you find the determinant of what? The whole of this matrix should fetch us what? 16. Okay? So let's deal with it. So here, -2 multiplying 1 multiplying -1. What are we getting? We are going to get what? So -2 multiplying 1 multiplying -1, you should be able to get what? +2. So I'll write a +2 there to indicate that. All right. So here should be +2. And then we have 2 multiplying 3 multiplying 1. That should fetch us what? 6, right? And we have 1 multiplying 1 multiplying x, and that should fetch us what? X. And when we come to the upward arrows too, we have 1 multiplying 1 multiplying 1, should fetch us what? 1. And then we have x multiplying 3 multiplying -2. And we should be able to get -6x. And lastly, -1 multiplying 1 multiplying 2. We should be able to get negative what? 2. -2. So once you're able to get their product, we'll just sum these product together. All right. So in doing that, we'll say that therefore I have 2 plus 6 plus x as the first sum, and then compare that to the upward sum, right? That should be what? 1 plus -6x plus -2. And all should be equal to what? All should be equal to 16. So now left for us to find the value of what? X. So here I'm going to fetch us 8. So here I'm going to get what? 8. Then here should be x. So the bracket, and then here to 1 plus -2, you should be able to get us what? -1, then -6x, and we equate that to what? 16. So what are we getting? We expand the bracket. We're going to have here to be 8 plus x. Then what are we getting? Here should be what? +1, then +6x, and that should be equal to what? 16. So we have x here, we have 6x here, and that should fetch us what? 7x, plus 8 plus 1 should fetch us 9, and that should be equal to 16. Let me create a space here. So therefore, we'll say that 7x should be equal to 16 minus what? 9, right? Minus 9. And so therefore, 7x should be equal to what? 7. So when we divide both sides by 7, what are we getting? We have x to be equal to what? +1. We have x to be equal to +1. So therefore, the value of x in this matrix should be what? 1. So let's take note of that. Question number 7. Given that -7p plus 14q is equal to -42 and 3p plus 12q is equal to 90, using Cramer's rule to evaluate the unknown and find the value of what? Of p minus q. Remember, here is an MCQ type, and so therefore, we are not interested in your workings, but at the end of the day, we are interested in finding we are interested in your answer. That's what I'm trying to put across here. So even if the question says use Cramer's rule to evaluate that should have been done where it is written type. So you should have used that rule to find the unknown values. But here lies the case, you are asked to find what? The value of p and q, and it's an MCQ type. You can use any of the methods to find it so that you get your answers very sharp in that way. So since you are not actually restricted, because this is an MCQ type, you just want to provide your answer. We are not interested in your solution or in your methods. We just want the answer. So you can use any approach to get your answer done in that way. But for it to be theory, then you should have restricted and go by what? The Cramer's rule. And I believe that is clear. Right. So here we can straight away use the simultaneous equation approach to deal with that, and that should be fine for us to get our value. So we have -7p plus 14q, and that should be equal to -42. So that should be equation 1. And we have what? 3p plus 12q, and that should be equal to 90. And that should be equation 2. So here too, we will follow our presentation on how to use calculator to solve for simultaneous equation. So we go to 5. Sorry, we first of all go to what? Mode. With my case, it's different. I just undertake 2 steps and I'm done. So with your case, you go to mode, you select 5, and you select this equation. Right? So once you're able to get this, then you start. So here, since you have p and q, the p part will represent what? The x, right? And the q part will represent what? The y. The p part will represent the x, and the q part will represent y. So when we get x, that is for p. When we get for y, that is for what? Q. Is that okay? So here we have -7, the first equation. Then we have 14 here. And then we have for the c part to be -42. Then we come to the second equation. We have 3 here. Then we have here to be 12. Then we have here to be what? 90. So what are we getting? So we have x to be equal to what? 14, meaning that x at this point is equal to p, and that should be equal to what? 14. What would be y, which is equal to what? Q. Let's see. So y is also what? 4. So once you're able to get the values, then we are done. Just write it. And therefore, you tell us that since we are asked to find what? P minus Q. Therefore, P minus Q should be equal to, I know P to be what? 14 and Q to be 4. So therefore, we'll say that P minus Q should be equal to what? 10. And that should be option what? B. And you are good to go. So let's take note of that. Question number 8. If X superscript T is a transpose of a matrix X, then the value of the absolute X superscript T is, so here we are asked to find the determinant after S has been transposed, right? How do you transpose a matrix? By transpose of a matrix, this is what we want to do. We interchange rows for columns or columns for what? Rows. That is the basic rule. We interchange rows for columns or columns for what? Rows. Either way that you go, you're still going to get the transpose of a matrix. You interchange rows for columns or columns for what? Rows. And I believe that is clear. So here we have matrix X to be equal to, so let's do the transpose straight away. So by transpose, I'll go by interchanging what? Rows for what? Columns. So this is my first row, 0, 3, 0. So that becomes the first column. So that becomes what? 0, 3, 0. Okay. And then the second row also becomes the second column. So I have what? 2, 1, 3. And then the third row becomes the third column. So I have what? 4, 2, and 2. So this becomes the transpose of X. So once you're able to get this, you are also asked to find the determinant of this matrix. Remember, here too, we can even use calculator to solve for the determinant of a matrix. But for the purpose of this presentation, we want students to appreciate how they can manually solve for the determinant of a matrix. And we go by that by using the upward arrows and downward arrows, and then we are good to go. So here, this is what we're going to do. We have 0, 3, 0, we have 2, 1, 3, we have 4, 2, and 2. So we repeat the first two columns to be added to it. That becomes 0, 3, 0, we have 2, 1, and 3. So once you are done, we start with the downward arrows, right? So we have what? Our first downward arrow forming at this point. Then here 2, forming at this point. Then here 2, forming at this point. Then we also move to this side, upward arrow, and then we get this as well. So here it is 0 multiplying 1 multiplying what? 2, and that should be 0. Any number multiplying 0 is 0, so we don't waste time there. So here is 0. Then here to 2 multiplying 0 is also 0. Then here to 4 multiplying 3 should fetch us what? 36. Here is 9 itself. 3 by 3 is 9. By 4, 36. Now here should be 0. 0 multiplying 1 multiplying 4 should be 0. Then 0 multiplying 2 multiplying 3 also should be 0. And then 2 multiplying 3 should be fetched as 6. Multiplying 2 should be 12. Okay. So once you are getting it, therefore, we'll say that absolute bar of what? X transpose should be equal to, so we have here to be what? 0 plus 36 minus 0 plus 0 plus 12. So I don't know, what are we getting? We are getting 36 here. We are getting 12 here. What should be our answer? That is 24. So the S transpose, determinant of S transpose is what? 24. And that should be option what? A. Then we are done. So let's take note of that. Let's move on to question number 9. Question number 9. Find the derivative of the function f of x is equal to negative 8x squared minus 4 cos x. So here we have f of x to be equal to negative 8x squared minus 4 cos x. Right? So here we are asked to find the derivative, that's the first change of this function. So we know that should be f prime of x. Here should fetch me what? 2 multiplying 8 and subtract 1 from the 2. So I'm going to get what? 16x, okay, minus. So here is also the product of two functions. We have 4 and then we have cos x, right? So I'll hold the 4 and then differentiate what? Cos x. So I have 4 here. The differential of cos x should result to what? Negative sin x. Then we say the differential of what? The product of two functions will result to addition. So I will say that plus, okay, And I'll come back and hold what? Cos x. And then differentiate 4, for which you know is a constant. That should result to what? 0. So therefore, we'll say that f prime of x should be equal to negative 16x. Then here, negative 4 multiplying negative sine x should fetch us what? Positive what? 4 sine x. Here, cos x multiplying 0 should be 0. So therefore, we'll have this as our final answer. So that's going to be negative 16x plus 4 sine x. And that's going to give us option C. Negative 16x plus 4 sine x. Question number 10. The function x squared minus 3x plus 7 has a turning point at. So here, we'll find the first derivative of this function. So we will say that f prime of x should be equal to, so differential of x squared should result to x. Differential of negative 3x should result to negative 3. Differential of 7 should result to 0 as a constant. So we'll say that at this point, the curve is at rest. So we'll say that at f prime of x, the curve should be equal, because at that point, the curve is no longer moving. And everything that happens with the curve is 0. It's motionless. It's no longer moving. It's like more like human being. If you're not working, you earn what? 0 wages, right? So that's the same thing that also happens here. So at the same point, the curve is at rest and no longer what? Moving. Okay? So at the turning point, we say that f prime of x is equal to what? 0. And so therefore, we'll say that 2x minus 3 should be equal to what? 0. So therefore, say that 2x should be equal to positive 3. Divide both sides by 2. Then we are getting x to be equal to what? 3 over 2. 3 over 2. But here we're asked to find a turning point. A turning point. So that's why you see only one possible option here as well. 3 over 2. If we were to be turning point, then we mean that should be what? A coordinate for x and a coordinate for what? Y. And how do you find that? Once you're able to get the turning point for x, you just substitute this value to the original function. The f of x is equal to x squared minus 3x plus 7. Whatever you get becomes the value of y. And that should give us a turning point for the curve. Remember, this is a maximum what? Sorry, this is a minimum function, because the coefficient of x squared is greater than what? 0. So at any time the coefficient of x squared is greater than 0, we call that curve or function as what? A minimum function. But if it is less than 0, that becomes what? A maximum what? Function. So let's take note of that. So once you're able to get the x, that becomes the turning point of x. If we were asked to find y2, the question I would say that has a turning point at, so mean that we have what? The coordinate of x and the coordinate of y, and should have substituted this 3 over 2 to this original function, so that whatever we get as value, that becomes the value of what? Y. So let's take note of that. So let's move on to question number 11. You see what I was talking about here? Actually, what I've said explain the whole of this issue. Find the turning points of the graph of y is equal to 2x cubed minus x to the power of 4. So the same approach. So we find the first derivative of the function, equate that to 0, and then whatever we get, we'll substitute all into this original function that you see here. And then we get the values of y. Simple. Okay? So we have y to be equal to 2x cubed minus x to the power of 4. So we'll say that differentiate y, differentiate x. What are we getting? So here we're going to fetch us what? 6x squared minus what? 4x to the power 3. Okay? So once we get that, then we'll say that at dy over dx is equal to 0. Then we'll say that 6x squared minus 4x cubed should be equal to what? 0. Okay? So here, this is what we can do. We can factorize some of the x out by saying that here it should be what? Say x squared into bracket 6 minus 4 what? X, and that should be equal to 0. So we're going to have x squared to be equal to 0, or 6 minus 4x to be equal to what? 0. You know, when you take square root, or you can plus or minus, we are getting x to be equal to what? 0. But here, when you have 6 minus 4x to be equal to 0, here fetch us 6, and that should be equal to 4x. Divide both sides by 4. What are we getting? We are getting what? 2 goes to 4, 2. 2 goes to 6, 3. So it becomes what? 3 over 2. So therefore, we'll say that we have what? X to be equal to 0. and then 3 over 2. But here we're asked to find the turning point of the graph. So once you're able to get the values of x, we will then substitute this value to this original function so that we get the values of y. And when we combine that to the x, we get the turning point for the graph. Right? So in this case, my turning, that's what I'm going to do. I'll just take my calculator. So go back to the normal function. So let's say we have this. So on your normal calculator, as you must see it like this, then you get this function y is equal to 2x cubed minus x to the power of 4 on your calculator. So you're going to have here to be what? You have here to be 2 alpha x, then it is what? Square, right? So you have here to be what? Sorry, cube minus, we have x to the power what? 4. So once you get this function on your calculator, all that you want to do is that you press solve on your calculator. That is below the shift, I think so. With my case, below the shift. So just press solve. So once you press solve, you see on your calculator, you see s question mark, or you see s equal to what? Question mark. Whatever you're going to see, once you get that, you want to solve for what? Say 0, right? So you just press 0, and after you press equal to sign. What were we getting? We're getting 0. So when x is equal to 0, you get y to be equal to what? 0. And in the same solve, you don't clean anything from your calculator. I just press solve, and we want to solve for what? 3 over 2, right? So we'll say that we want to solve for 3 over. So we have 3 divided by what? 2. And I'll press equal to sign. And I'm getting what? 1 point. So in a more fraction form, you should be able to get what? 27 over what? 16. So when also x is equal to 3 over 2, y is also equal to what? 27 over 16. The reason why we are doing this is to avoid the time where you will say that at s equal to 0, let me substitute whatever I see as, I'll substitute what? 0 in there. And at s equal to 3 over 2, I'll substitute that 3 over 2, whatever I see s in this function. That will going to delay your time to compute them individually. So once you get this function on the calculator, just press solve. Whatever you want to solve, just type. Let's say I want to solve for 2, I'll just press 2 and press equal to sign, and I'll get the value. If I want to solve for, let's say 1 over 5, okay, I'll just, once I type it, I press equal to sign, I'll get the value for 1 over 5 for the function. So that's how we go by, so that you get your work so done perfectly. So here, you're going to have what? Therefore, we'll say that we'll have the values 0, 0, that's this one, and then we have, and we have for 3 over 2, comma, 27 over 16. And that should give us option D, and you are good to go. So this is what we call the turning point. So the turning point will include what? The x value and the y value. So let's take note of that. Let's move on to question number 12. If a point moves on the curve, so we have the curve x squared plus y squared, and that's equal to what? 25. Then at 0, 5, we are asked to find what? The square y over dx squared is equal to. Then at 0, 5, the square y over dx squared is equal to. So here, we want to differentiate the function the second time. Okay, so we'll start with the first differential. So I will say that the differential of 2x will fetch more. The differential of x squared will fetch more 2x. Then the differential of what? Y squared, you follow the same rule of differentiating a function, but just that because we have y, to make it different from the x part, you say that you attach the y dx. You attach the y dx. Okay, so here, that's what I'm going to do. I will say that the 2 will multiply the coefficient of y. Okay, that becomes what? 2y. All right, but to show that I've differentiated y, I'll attach what? dy over what? dx. Assuming y was 3, that should have been what? 3. Then you have y what? Square, because we reduce here by 1. But to show that I've differentiated y, I'll attach what? dy over what? dx. If with respect to dy over dx, then it should be dy over dx. But with respect to y to any other variable, we say that dy over that variable. And you are good to go. So that is all the difference between the differential of x and then the y in that line. Okay. So once you're able to get this, we also know that the differential of 25 as a constant is what? 0. All right. So here, once you're able to get this, we will make dy over dx the subject. So this is what we're going to do. We'll say that dy over dx should be equal to, we're going to have here to be negative 2x, right? And then divide by what? 2y. Because when I introduce the negative 2 to join the 0, it becomes negative. Once I'm able to get that, I will then divide both sides by 2y. And I'm going to get what? Negative 2x over what? 2y. Okay? So this actually should fetch me what? The 2 can cancel the 2, so that should be negative x over what? Y. So once I'm able to get this, therefore I know that my dy over dx is equal to negative x and what? Y. But I was told to find what? The squared y over the s squared, right? So I need to differentiate this function the second time, okay? So I can rewrite this function to say that here it is equal to cross multiplication. Remember, here is out of 1. So I can multiply y by dy over ds and then multiply 1 by what? Negative what? X, right? So I'm going to have here to be what? Y multiplying dy dx, okay? And that should be equal to negative x. So here is going to be a product of two functions, okay? So I'll hold the y and differentiate what? Dy over dx. And then after that, I'll come and hold dy over dx and differentiate the y. And then differentiate the negative x2. So here, this is what we're going to do. I'll hold the y. The differential of what dy over dx should result to the second derivative. And that should be what? The squared y over ds squared. Very simple. So you have here multiplying the squared y over the s squared, right? So we said the differential of product of two functions result to addition, right? So we say plus. And after that, I'll come back and hold what? dy over dx. And then differentiate y. We said differential of y. When you differentiate y, to show that there has been a change, you attach dy over ds. So here the power is 1. So 1 multiplying the coefficient of y here is 1. And then subtract 1 from the 1. You're getting 0. In number to power 0 is what? 1. And then to show that we have differentiated y, we attach dy dx. And that should be equal to, here you multiply dy dx. Okay, and that should be equal to, so here, differential of negative s should fetch me negative 1. Okay, so once I'm able to get this, I know that dy over dx is equal to what? Negative s over y, right? From this equation, I can know that dy over dx is equal to negative x over y. So wherever I see dy over dx, I will substitute negative y over x in there. So I will say that I have my y here, I have my d squared y, the s squared, plus, so I know here is dy over dx, so I'll have what? Negative x y. Then I also have here to be negative x y. And that should be equal to negative 1. So we're also given this point that at 0.5, the squared over the s squared should be. So here, once you're able to get to this stage, wherever we see x, you substitute 0 there. Whenever you see y, you substitute what? 5 there. Is that okay? This is for x and this is for y. Okay. So this is what we're going to do. We have 5 here. Then we have what? The squared y over the s squared. Plus, so here it is 0 over 5. Okay. 0 over 5. And that should be equal to negative 1. In number multiplying itself as 0 should be 0. In number multiplying 0 should be 0. Okay, so the whole of here will amount to 0. And at the end of the day, you are going to have what? 5 the squared y over the s squared should be equal to negative 1. So let me bring that here. So I will say that here I'll have what? 5 the squared y over the s squared should be equal to negative. So I will then divide both sides by 5. So what am I getting as my the squared y over the s squared? And that should be equal to negative 1 over 5. And I'm done. So this is how we also deal with this kind of question in that line. So here the answer should be what? D, negative 1 over 5. So let's take note of that. Question number 13. We have y to be equal to 5 exponential 3x plus sine x. So we're asked to find dy over what? Dx. So y is equal to 5 exponential sine 3x plus sine x. So we are asked to find dy over dx. So we said that the differential of an exponential function, you first of all need to differentiate the function on top of the exponent, and after that you multiply the result by the coefficient of the exponent. Okay, so differential of 3x should be 3, Multiplying 5 should fetch me what? 15. Okay. After that, I will then repeat what? The exponential function 3x. So I'm done with the differential. Plus, differential of sign should result to what? Cos. So that should be cos x. And I'm done. Just one step. Okay. So that should be 15 exponential sine 3x, exponential function 3x plus cos x. And what are we getting? So we have what? Option B as our answer. So the differential of sine is going to result to cos, and the differential of cos is going to result to negative sine x. So let's take note of that. If we have a relation to sine, if we have a relation to x, then we'll get that in that line. So let's take note of that. Question number 14. We have xy plus what? 2y, and that should equal to what? X squared. We are asked to find dy over dx. It's an implicit function, so we are asked to find dy over dx. So here too is a product of two functions, okay? So this is what we're going to do. We hold the x, we differentiate the y. So I will say plus, then we hold the y, we differentiate the x, right? So when I hold the x, I'll come and differentiate the y. So we said differential of y, to show that you have differentiated, right? You must add dy over dx. And that should be equal to dy over dx. Because this is just one exponent. I mean, the power is just 1. So that's why it's resulting to dy over dx. After that, I will say plus. Now I have my y here. Differential of x should be what? 1. Okay? Plus. Then here too, I have 2y. So we said differential of y should be what? Dy over dx. So that should be 2 dy over dx. And that should be equal to differential of x squared should fetch me what? 2x. Okay? So once you're able to get this, that's fine. The next step is to make our dy over dx the subject. Is to make our dy over dx the subject. Okay? So here, this is what we're going to do. We will say that I have x, I have 2 here. So I will say that I have x dy over dx plus 2 dy over dx. And that should be equal to 2x. And I'll ensure that the y here, which is the same thing as y multiplying y is the same thing as y, will join the 2s and making it to a negative y. So I'll factor dy over dx out, and that will fetch me dy over dx into bracket x plus 2. And that should result to what? 2x minus y. So at this point, all I would do is to divide both sides by x plus 2, divide both sides by x plus 2. So therefore, my dy over dx should be equal to 2x minus y dividing x plus what? 2. And that should give me which of the options? So we have D. Is this true? Yeah. So we have what? 2x minus y, and then all divided by it is x plus 2, not minus. So here we can't accept D. We'll go for what? B, which is what? 2x minus 1 x plus 2. So that should be what? Option B. So let's take note of that. Question number 15. We have the squared y over the x squared, and that should be equal to 3x minus 2. So when you say this, then we are asked to find or determine y. Then you want to integrate this function back to its original form. So you have an elongated x. You have an elongated x. When you integrate the squared y over the x squared, you're going to get what? Dy over dx. And that should be equal to, you also want to integrate this. So we have what? The integral of what? 3x should fetch me what? 3x 1 plus 1 divided by 2. Then here it can also be written as what? 2x to the power of 0 plus 1 divided by 1. Because this is an indefinite integral, we introduce what? Constant, say c. So therefore, we have our dy over the x to be equal to 3 over 2 x squared minus 2x plus c. Okay. Then we also integrate this again, we will get y, and that should be equal to, so here too we have 3 over 2 plus 1 divided by 3 minus 2x to the power of 1 plus 1 divided by 2 plus cx, that's 0 plus 1 divided by 1 plus ad. Because it's an indefinite integral, so when we integrate, we introduce a constant. By indefinite integral, we mean that the function has no what? Limit. But if it's a definite integral, the function will have a limit, right? So we therefore say that y should be equal to, so 3 over 2 divided by 3 should fetch me what? 1 over 2 x cubed minus s squared plus cx plus d. And that should be which of these options? So we have 1 over 2 s cubed minus s squared plus cx plus d. And that should be option, I think is A. So we have y is equal to 1 over 2 s cubed minus s squared plus cx plus d. All right. So this is what we call an indefinite what? Integral. So we also have a definite integral like question 16. Evaluate 131 into bracket 6t cubed minus 3t plus 1 dt. So you're asked to evaluate it. This is what we call a definite integral. So here we can even use calculator to solve for it. So by a definite integral, you have a limit. So the 3 is the upper limit and then the 1 is what? The lower limit. So let's take note of that. So this is how we go by using the calculator to solve for a definite what? Integral. Because we just want to find a value for that. So on your calculator, you just locate this function, your elongated x dx, this. So once you're able to get this, then you see on top here, we have the box on top, that should be 3. And then the down here should be what? 1. And then when we come to this box, that's where we have the function. But here, remember, we're using t in this function. So here, we want to use x. So meaning whatever we get becomes the same thing as the t when we get for the x, I mean. So that's going to give us what? So we have here to be, so into bracket, we have 6. But we don't have t on the calculator, that should be x for now. So s cubed, then minus 3x plus 1. Then we have our bracket close. So I don't know, you see what you're going to get. So once you are done with that, with my case, you get the answer straight away. But yours, once you are done, you just press equal to sign, you get what? The answer to what? 110. So that's how it should be when you are using what? The calculator. And that should fetch us what? Option what? A. But if you want to solve it manually, we have a dedicated video on the channel. Do well to go through the playlist on quantitative methods. You see that video and you go through how we solve a definite integral using, after integrating, you just substitute the values, find the difference between the upper limits and lower limits after the integral of the function, then you're good to go. That's how but we have a video dedicated for that. So kindly go through so that you get to know how we integrate by a definite function. Okay, so let's take note of that. Question number 17. So we have y to be equal to x into bracket s cubed minus x plus 1. Okay, so before we can even integrate this function as a definite integral, we must first expand this function. So the x will multiply s cubed, x multiply negative x will multiply 1. So we're going to fetch us what? X multiplying s cubed, we are going to get what? X to the power of 4. Then x multiplying negative s, we're going to get x to the power of 2. Then x multiplying 1, we're going to get plus what? X. So once you're able to expand it out to this state, it's at this point that we're going to apply what we call our elongated what? X. So here we have here to be 1, we have here to be negative 1. So all dx. All right. So at this point, we will say that we want to integrate this, right? So integral of this is going to fetch us what? X to the power of 4 plus 1 divided by 5 minus, then this one 2, we have x to the power of 2 plus 1 divided by 3, and we have here to x to the power of 1 plus 1 divided by 2. Okay, we call this a definite integral. We have the limit here 1, negative 1. Okay, so we have 1, negative 1 here. Okay, so once you're able to get this, then we'll find the substitution of 1 into this expression and the same time substitution of negative 1 to this same expression. After that, we'll take the difference between the two. Okay, so that's what we're going to do. Let me bring it down a bit. So we're going to have here to what? X to the power of 5 divided by 5 minus x to the power of 3 divided by 3 plus x to the power of 2 divided by 2 with our limit 1, negative 1. So that's what we're going to do. We'll find our calculator and then get this function on the calculator. After that, we'll solve for 1 and then negative 1. So then bring in our calculator. So we have it here. Okay, so let me pull it here so that we can see. So here I'll type this full function on this calculator, right? So this how it's going to be. So I want to have here to be x alpha x to the power of what? 5. Okay, and then divide by 5. Then minus. Then we have alpha x to the power of what? 3. And then divided by what? 3. Then we have plus. We have alpha x to the power 2 and then divided by 2. Okay, so once you're able to get this on our calculator, this is what we're going to do. We will say that we press solve and we want to solve for 1. So we want to solve for 1. So we type 1 and then we press equal to sign, right? And we're getting what? 1. So the same thing, you just press solve and then press 1. So once we get the function on the calculator, you press solve and then you type 1 and you solve for 1. And you are getting what? 11 over 30. So 1, you should be able to get 11 over 30. So once you're able to solve for 1, you say minus. Then you do same. You press solve, you solve for -1, press equal to sign, and then press another equal to sign. I'm going to fetch us what? 19 over 30. All right, so when you take the difference between the two, then you should be able to get your final answer. So here we're having 11 over 30 minus 19 over 30. And what are we getting? Supposed to get what? -4 out of what? 15. This is how we find the integration by a definite what approach. Okay, so once you integrate, you just substitute the upper limit in that expression, and then you substitute the lower limit also in the same expression. So you take the difference between the two, and that will fetch you your result. All right, so this is how we integrate. So let's take note of that. So once you get this on your calculator, just press on the calculator and then type the value you want to solve, and then press equal to sign, and you get the value, and then you move on in that line. So let's take note of that. So let's move on to question number 18. So here we're getting what? -4 out of what? 15, and that should be what? A. So question number 18, we have dy over dx to be equal to 6x plus 2. We are asked to find c given that y is equal to 3 and x is equal to what? 1. So we are asked to find c given that y is equal to 3 and x is equal to what? 1. So we need to integrate this. So we have an elongated x. So when we integrate dy over dx, we are getting y. Okay. When we integrate 6x plus 2, first it should be what? 6x to the power of 1 plus 1 divided by 2 plus 2x to the power of 0 plus 1 divided by 1. Remember, 2 can be written as what? 2x to the power of 0. And same thing as what? 2. Because any number to the power of 0 is what? 1. So when we add the 1 to the 0, we then divide by 0. But because this is an indefinite integral, we introduce our constant, say c. That's what the question is asking us to find, c. Okay. So once you're able to get that, then that is fine. We will therefore say that we have our y to be equal to 2 goes to how many times? 3. So we have 3x squared plus here we have what? 2x plus c, right? But we know that y is equal to 3 and x is equal to what? 1. So we can do substitution. Whenever we see y, we substitute 3 there. Whenever we see x, we substitute what? 1 there, so that we get to know the value of c in that regard. So let me create a board here for this simple expression. So I know y to be 3, so I have here to be equal to, so I know x is what? 1. So 1 squared plus 2, also multiplying 1 plus c, right? So I have here to be 3, I'm getting here to be 3, here to be 2, here to be c, right? So I have here, when you add 3 plus 2, you are getting 5. So minus 5 should be equal to a c, and I'm getting c to be equal to what? -2. So therefore, c is equal to what? -2. So let's take note of that. So that should be option what? D. Question number 19. Given that y is equal to, so we have y to be equal to, into bracket 2x cubed plus 2x squared plus 1 to the power of 5. We are asked to find dy over dx. That's the first derivative of this function. To differentiate this function is very simple. You said that differential of y should fetch us for dy over dx, right? And that should be equal to, so here is what you're going to do. Actually, you can use chain rule to differentiate this, but you can also differentiate in a simple way. This is what you're going to do. First of all, have to bring the 5 in front of this expression. So we have 5 here, okay? And after that, you differentiate what? The function term by term. You see, we have 2x cubed, 2x squared plus 1. So I'm going to differentiate this term by what? Term. So I'll have my bracket. Differential of what? 2x cubed. Want to fetch me what? 6x squared. Okay. Plus differential of 2x squared. Want to fetch me 4x. Differential of 1 is 0. So I won't take that into consideration. After that, the third step is that I'll repeat this whole expression here. That should be what? 2x cubed plus 2x squared plus 1, okay, to the power 5, and then subtract 1 from what? The 5. So first, you bring the 5 or the power in front of what? The expression of this. After that, you differentiate each term in this expression, and we're getting 6x squared 4x, right? After that, you repeat this whole expression, which is what? 2x cubed plus 2x squared plus 1 with the power 5, and then subtract 1 from the 5, and then that is all. So I don't know, you're going to have what? 5 into bracket 6x squared plus 4x, okay, into bracket 2x cubed plus 2x squared plus 1 to the power what? 4. So you realize that here you can expand it to get a simple answer, but based on the options here, you realize that they didn't expand. So we can say that therefore our final answer should be 5. So we are looking out for the one with 5. So C is out. So let's start from A. So here we have 5, but it should be 6x squared. So not 2. So A is also out. So when we come to the B, we have 5, 6x squared. We have 4x. And we have here to what? 2x cubed plus 2x squared plus 1. Let's check that of the D part 2. The D part 2, we have what? 5, 6x squared, but it's what? 2. So you see that if you don't take care, you might choose a wrong answer. So meaning that we are going for option what? B, which is 5 into bracket 6x squared plus 4x into bracket 2x cubed plus 2x squared plus 1 to the power what? 4. And that should be option what? B. So let's take note of that. Let's move on to question number 20. Find the expression for y given that dy over dx is equal to x squared multiplying square root of what? X. Okay, so how do you go by finding what? This expression for y given the first derivative of y. So we have our dy over dx to be equal to square of x square root of x. Remember, this same expression can be written as dy over dx to be equal to x squared, okay, multiplying. Realize that square root of x is the same thing as what? X to the power what? 1 over 2. So when I'm applying my law of indices, I will say that dy over dx, okay, should be equal to, so here I'll add the exponent. So 2 plus what? Half, we're going to fetch me what? X to the power 5 over 2. So once I'm able to get this, now I'm able to simplify this whole function to a simplest form, okay? So therefore, I will say that if I want to integrate this, I know my dy over dx to be equal to x to the power 5 over 2. So I have my elongated x here. I have my elongated x for this part too. So I know that when I integrate dy over dx, I'm getting y, okay? But remember, this is an indefinite integral. So after that, you introduce your constant, say c, all right? So I want to integrate this. So this is what I would do. I would say that x to the power 5 over 2 plus 1, and then divide the result by what? That. So when I added this to this, what are we getting? I think we are going to get 7 over 2. I hope that is true. We're going to get 7 over 2. But because this is an indefinite integral, we introduce constant c. So therefore say that when I try to rationalize this or find the reciprocal of 7 over 2, that is a denominator of x to the power 5 over 2 plus 1. It should be equal to 2 over 7 x to the power what? 7 over 2 plus c. And this is how you find the value or the expression for y, given the first derivative of y, which was x squared square root x. So we are getting what? 2 over 7 x to the power 7 over 2 plus c. And that is how it should be. So let's take note of that. And that should be for which option? That should be for option what? D. So let's take note of that, option D. Now let's go on to question number 21. Question number 21 says that we have v to be equal to u, 2u cubed minus u squared, all divided by what? 3u, where we have u not to be equal to what? 0. So we are asked to find the v over what? The u. But before we can do this, you must first of all simplify or break this into its simplest form. Must reduce the power to its simplest so that we can easily what? Differentiate, right? So that's what we're going to do. We can rewrite this same as what? 2u cubed divided by what? Divided by 3u divided by 3u, right? Minus u squared divided by what? 3u, all right? So once you're able to get this, we apply our laws of indices for the u. So when the law says that when I'm dividing and I have the equal what? Base, I'll subtract the denominator exponent from the numerator what? Exponent. That's what I'm going to do in that particular case. So let's take note of that. So what are we getting? We have v to be equal to 2 over 3, and that should give me u to the power of 3 minus 1. Remember, the exponent of u here at the denominator is what? 1. So when I subtract that, this is what I'm getting. Then minus, I have what? My 1 over 3 u squared. Then I know that here is also what? 1. So subtract 1 from here. Because here is what? 3. So it means that 1 over 3. So what are we getting? We have v to be equal to 2 over 3. Then u to the power 2, right? Minus. And I have here to be 1 over 3. And I have u. So once able to get this down, I've been able to simplify or reduce it in its simplest form. I can therefore go along to differentiate this function. V is equal to 2 over 3 u squared minus 1 over 3 u, right? So let me create a space for this differential. So I would therefore say that if I have v here, let me differentiate straight away. So we would therefore say that differentiate v differentiate what? U should be equal to, so here I'll then multiply. So that becomes what? 2 multiplying the coefficient of what? U squared, and that's what? 2 over 3. And I have my u squared minus 1 minus 1 over 3 multiplying the power 1 here, okay? And I have my u minus what? 1. This is how we differentiate, right? So I don't know, what am I getting? 2 multiplying what? 2 over 3 is going to fetch me 4 over 3. Then I have u. Because when you take 1 from 2, I'm left with what? 1. So u minus. And here 2, I'm going to fetch me what? 1 over 3. Remember, 1 minus 1 is what? 0. So any number to the power 0 is what? 1. So I don't know, I'm going to get what? 1 over 3 as my dv over what? Du. Okay. So therefore, to factorize or simplify it further, I can say that here, I can have 1 over 3 here, 1 over 3 here. I can write this as what? 1 over 3 into bracket 4u minus 1. And I hope you believe that, because when you expand 1 over 3 by 4u, you are going to get 4 over 3u. When you expand 1 over 3 by negative, we're going to fetch us what? Negative 1 over 3. So this is the same thing as what? This. So let's take note of that. And that's going to give me which of the option? That is option what? C. That is option C. So I have 1 over 3 4u minus 1. Option C is true. Now let's go on to question number 22. Differentiate with respect to x. So we have here 1 over x into bracket 3 plus 4x plus 5x squared. All right, so we are asked to differentiate this function. Before you can differentiate, as I always say, as I used to say, you must always ensure that you reduce the expression in its simplest form so that you can easily what? Differentiate or integrate, whatever we are asked to do. But here we are asked to differentiate. So we reduce the expression given here to its simplest form so that we can easily what? Differentiate, right? So this is what we're going to do. This same expression can be written as what? 3 over x. Or I'm going to expand 1 over x by the whole of the term in this bracket. And with the first one, I'm getting 3 over x plus, and then 1 over x, I'm getting what? 4 over x divided by x plus here 5x squared divided by what? X. So I don't know that I can write this by saying that here should be 3 over x. My law of indices will help me that the x can cancel this as I'm getting what 4. And I can also reduce this x by 1 to this. So that's going to fetch me 5x. But here is what 1 taken from 2. I'm left with what x. That's 1. So once able to get this, now I can easily work out by differentiating this function. All right. So let's say here is equal to y in that line. Okay. So I will therefore say that my dy over the x should be equal to. So here, remember, before you can even start to differentiate this function, you must even have to simplify this also further. So I can say that y can also be written as what? 3x to the power negative 1. The x 3 over x can be written as what? 3x to the power negative 1. It's like more like this. If I have 1 over 2, I can write this as what? 2 to the power negative 1. If I have 1 over y, I can write this as what? Y to the power negative 1. If I have, let's say, x over v squared, I can write this as what? X multiplying v squared to the power of negative 2. And you can do it for any other division in that line to write them in a linear form. So I have 3 over what? X plus 4 plus what? 5x. So once able to get to this stage, I can then easily differentiate. So I would therefore say that dy over the x should be equal to, so here I'm differentiating. So here the negative 1 multiply the 3 and subtract 1 from the negative 1. So I'm going to get what? 3 multiplying 1, x to the power of negative 1 minus 1, okay, plus. So we said differential of a constant going to result to 0, plus differential of 5x, I'm getting what? 5, okay. So at the end of the day, we'll say that our dy over the x should be equal to negative 3x to the power negative 2 plus what? 5. And remember, I can rewrite this as, let me bring it here, that my dy over the x should be equal to negative 3 over what? S squared plus 5. I hope you agree with me on that, because this actually is the same thing as what? Negative 3x to the power of negative 2 that I can see here. So I can write it as what? A fashion like this. So let's take note of that. So therefore, to write this in a more simplified way, I have 5 minus 3 over what? S squared. And this is what you get at the end of the day when you differentiate what? 1 over x into bracket 3 plus x plus 5x squared. So let's take note of that. And that's going to fetch us what? Option A. Option A as the right answer. Now let's move on to question number 23. Which of the following is an indicator of a local maxima? We said that for a local maxima, that is a maximum curve. What does a maximum curve look like? We are saying that always the line x is equal to A will actually meet it at this point of tangency, and also the curve lie below the line x equal to 1. And for a maximum curve too, we said that if I have as squared plus bs plus c to be equal to 0, we are also saying that the coefficient of s squared, if it is a maximum curve, then we are saying the coefficient of s squared should be less than what? 0. So we say that a should be less than 0. These are the parameters to indicate that whether a curve is a maximum or a minimum. So if it is a maximum, then a as the coefficient of x should be less than 0. And also, a curve should actually lie below the line x is equal to 1, where they meet at the point of tangency, or the point where the curve is at rest, or at the point called critical point, or the stationary point. Okay, so that is 1 or 2 indicators for it. And so we're also saying that when we also differentiate what? A maximum curve for the second time, that the squared root over the s squared, the result you get should be what? Less than what? 0. So if you are getting less than 0, that means that the curve is actually what? A local maximum, or a maximum what? Curve. So let's take, so these are the parameters to indicate whether a curve is a maximum in that line. So here we are saying that a curve should lie below the line s equal to what? A. We call this line the line that touches this curve at the point of tangency. Then also the coefficient of what? S squared should be what? Less than 0. And then the differential of that function for the second time should result to, in terms of its value, should be less than 0. So once it's less than 0, then we have what? A maximum what? Curve, right? And that should be which of these options? That should be option what? B. So let's take note of that. That should be option B, and let's take note of that. So we have what? B to be a local indicator of a maxima. So we have B. Now, question number 24. We have y to be equal to negative cos x. We are asked to find the fourth y over the x to the power 4, right? So we are asked to differentiate this function by 4 times, to the 4th time. So we have y to be equal to negative what? Cos x. You know the base rule for differential of what? When we differentiate sine x with respect to x, we are getting cos x. Okay? But when we differentiate what? Cos x with respect to x, we are getting negative sine x. So these are the base rule for the differential. So let's go by this. So here we have what? Our dy over dx to be equal to, so here, since we said that differential of cos x is going to result in negative sine, we're going to fetch us for negative sine x, because cos was already having a negative. So when we differentiate cos, we are getting negative sine, and that's going to negative. So we have what? Our dy over the x to be equal to what? Positive sine x. And then second derivative, we have the squared y over the x squared should be equal to differential of sine. We said it should result to what? Cos x, right? Okay, so let's continue from here. So we'll say that the cube y over the s cube. So we are differentiating this function the next time. So differential of cos x should result to a negative sine x. All right. So, and we have last one, the fourth y over the x to the power 4 should be equal to, so we also want to differentiate sine x. We said sine x, differential of sine x should result to what? Cos x, right? So here, since it has negative, it's going to result to what? Cos x. And that is going to give us the fourth y over the x to the power 4 should be equal to what? Negative cos x. Negative cos x. And that should be which of the option? And that should be which of the option? Option what? D. So let's take note of that. Question number 25. We have y to be equal to x carrying what? X. So let me clean some space here so that we use. So let me clean some part here so that we can use this for our presentation. So we have y to be equal to x to the power of x. At any time you are seeing a function of this nature, then you are thinking about what? A logarithm function. So here we can't easily differentiate this function, but rather we can do so when we apply log on both sides of what? This equation. So I will say that by convention you can write log as what? Ln. So we attach ln to both sides of the equation, right? So the differential of what? Y with respect to a log should be equal to what? Dy over dx, right? Because we said differential of y should be dy over dx. If with respect to x, then it should be dy over what? Dx. But for the log, once you have done the differential of that particular function, you then divide by the original what function, say y. So this is how we differentiate a log function. And that should be equal to, so here too, before we can even differentiate this, you must even bring the x, because but per the laws of log, when we have this, it is a power law. So the x should come as a coefficient of log x, right? So that should be x log x. So what are we seeing here? Now we are seeing what? A product of two functions. We have x on its own and we have log x also on its own. All right. So we hold the x, we differentiate the log. After that, we come and hold the log x and we differentiate the x. That's what we are doing in this case. But we have already differentiated this. We have already differentiated the log y. So we continue to repeat that in that line. So let me bring that here. So I will therefore say that here I have my dy over the x, or dividing y. So here should be equal to, I'll hold the x now, differentiate what? Log x. So I have x here. Differential of log x, or we know differential of 1 is going to, differential of x is going to result to what? 1. So since it's a log, I will say that it should be 1 and then divided by what? X. Okay, because we said when you differentiate, then divide by the original function in question. So the function here is what? X. So when after differentiating x, I will then divide by x. Okay, then plus. Since this is a product of two functions, once I hold the x, I'll come back and hold the log Sn and then differentiate what? The x2. Is that okay? So that's going to give me what? Log x. And the differential of x here should be what? 1. Okay. So once I'm able to get this, that's fine. Therefore, I will say that dy over dx should be equal to So I can say that the whole of this y can multiply this, right? But remember, this s can cancel this s, isn't so? So x here can cancel this s. So we are left with what? Y into bracket 1. Everything going to result to 1 plus log x. Because 1 multiplying this is going to result to what? Log x. So that's what I'm going to get, because the whole of y cross multiplication will multiply this, and then 1 will multiply what? Dy over dx, as we are getting here. But I know that here, you know that y is equal to what? We know that y is equal to what? Y is equal to log, y is equal to x to the power x, right? So whenever I see y, I will substitute x to the power x. So I will therefore say that my dy over dx should be equal to x to the power x into bracket 1 plus log x. And that's what I should get at the end of the day. And that should be which of the options below here? That should be option what? B and D. So we have option B and D featuring the same result. You can clearly see B, B and D. X to the power x into bracket 1 plus log x, x into bracket 1 plus log x. So we have what? B and D. So any way that you shade, you get that. This is more like a practice question. So assuming you encounter such a question in future, then you just shade the two and then you'll be marked, or just shade any one of these and you mark what? Correct in that line. So let's take note of that. Question number 26. The function f of x is equal to x to the power 4 divided by 4 plus x to the power 3 divided by 3 minus 3x squared plus 20 has all the following turning points, except we said a turning point. At the turning point, the curve is at rest, and so therefore the y over the x should be equal to what? 0. Now I hope you remember that. So here, all I want to do is to find the y over the x and then find the values of x where the y over the x is equal to what? 0. So we therefore say that our f prime of x should be equal to, so here we can say that here should be, remember, we can rewrite the same expression as this before even start with the differential. So we can rewrite this f of x to be equal to 1 over 4 x to the power 4 plus 1 over 3 x to the power 3 minus 3x squared plus what? 20. So therefore, if I want to differentiate for the first time, then 4 multiplying 4, what am I getting? Multiplying 1 over 4 x to the power 4 minus 1 plus 1 over 3, right? Multiplying 3x to the power 3 minus 1 minus 3 multiplying 2x to the power 2 minus 1. We said the differential of what? Constant as 20 should result 0. So we have here to be what? 20x to the power 0, right? So that should be what? This. So that should be, we have here to be what? 20 multiplying 0 x to the power 0 minus 1. And that should result to 0 at the end of the day. So we are getting here 4 will cancel 4. We are getting x to the power 3. Then here too, we are getting x to the power 2. 3 can cancel 3. And here we are getting what? 6x. And we are getting 0 here. But we said at the turning point, f prime of x or dy over dx should be equal to what? 0. So once we know that s cubed plus s squared minus s is equal to 0, therefore we can find our value. So here too, on your calculator, this is what you're going to do. You go to mode on your calculator. Okay, with my case, it's different. So when you go to mode on your calculator, you then select 5 and then you locate this equation that have as cubed plus bs squared plus c plus d. This equation. Okay, so once you're able to get this, then you start to put in the coefficient of s cubed, s squared, and then x, and even the constant, that is the d. So here we have what? The coefficient of s cubed to be what? 1. So we press 1, press equal to sign. Here to s squared, we have the coefficient to be 1. So we press 1, press equal to sign. Here to the coefficient of what? C, the coefficient of x here is what? Negative 6. So that becomes what? 6. And then press equal to, and then the d should be what? 0. So I don't know, what are we getting? We have x1, x1 to be 3, and then x2 to be 0, and then x3 to be what? 2. So at the end of the day, we have the turning point for x to be negative 3, 0, and 2. So this is how we use calculator to solve for that. So once you are getting this for the turning point of x, the question is saying that has all the following turning points except, so we have negative 3 here, which is here, okay. We have 0 here, which is here, and we also have 2 here, which is here. So meaning that out of these, we have 0, 2, and negative 3. It's only 4 which is not part of this turning point, and that should be what? The only exception, and that should be out. So we have D as our possible option. So let's take note of that. Question number 27. We have f of x to be equal to s cubed minus 2x plus what? 10. The question is saying that then, if we have f prime of 2, what are we getting is a question mark. So meaning that we need to differentiate this function for the first time. After that, whatever we get, we substitute 2 into that expression. So we say that f prime of x should be equal to, so differential of what? 3, differential of x cubed should result to what? 3x squared. Differential of what? 2x should result to 2. Differential of what? 10 should result to 0, right? So therefore, we say that f prime of 2 should be equal to, so here we have 3 into bracket 2 squared minus 2. What are we getting? 2 squared is what? 4. 4 multiplying what? 3, we are getting 12 minus 2. So what are we getting? We are getting 10, all right? We are getting 10, and that should be option what? A. So let's take note of that. Question number 28. Question number 28, we have y to be equal to negative 1 over what? S squared plus square root x minus 1 over what? Square root x. Remember, we can write all this in a linear form by saying that y should be equal to, so here I can write this as well, negative 4x to the power negative 2. I hope you agree with me on that. Then also, square root x can also be written as x to the power half, but we know square root is the same thing as half. And here too, you can also write this as what? 1x to the power negative half, because the square root, so when it joins the 1, it becomes what? Negative half. So once I'm able to convert this to the exponential form, then I can easily differentiate this function. So I would therefore say that my dy over dx should be equal to, so when I differentiate this, or differentiate negative 4x to the power negative 2, I'm getting what? 4 multiplying negative 2 x to the power negative 2 minus 1 plus 1 over 2 x to the power 1 over 2 minus 1. Then we have here to be what? 1 multiplying what? Negative 1 over 2 x to the power negative 1 over 2 minus 1. So what are we getting? What are we getting here? We are getting what? Positive 8x. So here is 2, right? So minus 1, I'm getting what? Negative 3, okay? Plus, then here 2, what are we getting? We are getting 1 over 2 x to the power negative 1 over 2. Then here 2, we are getting what? Positive, right? Because we have negative 1 multiplying negative half, and we are getting positive what? 1 over 2, and we have x. Here is negative 1 over 2, here is negative 1. So what are we getting? We are getting what? Negative 3 out of 2. And I hope you accept that. So once you're able to get to this stage, we would therefore say that our dy over dx, our dy over the x should be equal to, so here I can write this as what? 8 over what? S cubed plus, then here too I can write this as what? 1 over 2 square root x, okay? And I also say plus. Here I can also write this as what? 1 over 2 square root x to the power 3. Square root x to the power 3. Meaning that the square root can multiply what? The 3. And we are getting, when we have square root x to the power 3, the same thing as what? X to the power 3 multiplying 1 over 2. And we are getting what? X to the power 3 over 2. It's the same thing as this. So at the end of the day, what should we get at the end of the day? So we have 8 over s cubed plus 1 over 2 square root x plus 1 over 2 square root what? X to the power 3 in there. So let's see which of the option will meet this criteria, and then we are good to go. So A is out, A is out, B is also out. Okay, yeah, B is also out, C is also out, right? So therefore we can go for what? D, none of these, right? So that's how it should be, because This is what we are getting at the end of the day. So let's take note of that. Question number 29. We have been given some preamble to actually solve for 29 and 30. Use the following to answer question 29 and 30. The total cost function in thousands of euros for manufacturing S manipulator per year given us. So we have Cx to be equal to 375 plus 25x minus 0.25 s squared. 0 less or equal to s less or equal to 50. So we are asked to, what is the cost of producing the 31st manipulator using the marginal cost function? So by marginal cost function, we need to differentiate what? The original cost function for the first time. So we'll say that our cost of x should be equal to what? 375 plus 25x minus 0.25 s squared. So by the first differential of this function, that's going to result to a marginal cost function of x, and that should be equal to differential of 375 should be 0, differential of 25x should be 25 minus differential of what? 0.25, meaning that we are multiplying 2 by 0.25 and subtract 1 from the 2, and that should result to 0.5x. That should result to 0.5x. So let's take note of that. So once you are getting 0.5x, since we are asked to produce the 31st manipulator, it is actually very simple to go. Remember, in our production setting, for us to get the 31st manipulator, we know that our cost of producing is within the range of what? X greater than or equal to 0 and less than or equal to what? 50. Okay, and we are asked to produce a 31st manipulator, meaning that for us to calculate that 31st manipulator, this is what we need to do. This is what we need to do. We know that the total cost or additional cost of producing what? Or let's take it from this direction. We know that the cost of producing what? X manipulator was given us for 375 plus 25x minus 0.25 s squared, right? So for us to produce one additional manipulator, that can be written as what? C into bracket x plus 1. That is the marginal cost of producing one manipulator. Okay, so that's what we are asked to find. So we are saying that always the marginal cost of producing that additional manipulator should always be the cost of that one together with the original or normal level of production. That should be equal to that level or that position we are producing, and that should be equal to that level or that position we are producing. Okay, so remember that 31st manipulator is just one what? Manipulator, just one manipulator or one quantity or one product. All right, so for us to get the actual production level at 31st manipulator, we will say that the cost of x, that's our normal production, plus 1 should be equal to that particular position or that particular manipulator we are producing as a marginal cost of 1. Okay, so we say that x plus 1 should be equal to 31, and therefore we say that x plus 1 should be equal to 31. Therefore we say that 31 minus 1, and we have s to be equal to 30. So at the 31st manipulator, we are producing what? X. We are producing 30 what? Manipulators. So we are asked to find this using the marginal cost function. So therefore it should be equal to, whenever we see x, we substitute 30 there. So we have for 25 minus 0.5, 30. So what are we getting? We have here to be equal to 25. 0.5 multiplying 30, we are getting 15, and we are getting here to what? 10. But remember, we were told that it should be in thousands of euros. So mean that you multiply the 10 by what? 1,000. I don't know what are we getting? When you multiply 10 by 1,000, we are getting what? 10,000. And that should be option what? C. So here it should be what? 10 multiplied by what? 1,000. And we are getting 10,000. And that should be 10,000 euros at the marginal cost of producing what? One manipulator, which is at the 31st position. Then question 30. What is the exact cost of producing the 31st manipulator using the total cost function? So they say follow the same preamble. If you are producing 31st manipulator using what? The exact total cost function, then we are not going to differentiate. We're going to use the same what? Function that was given in question here, right? And we do that by saying that we will compare that 31st manipulator, that should be what? X plus 1 compared to the original level of production. That should be the cost of x, right? So we know x to be what? we know x to be what? 30. Remember that x is 30. So here we're going to have here to be what? 30 plus 1, we are getting 31. Okay. And then you have here to be what? 30. So this is what we're going to do. We'll substitute 31 into this cost function and then substitute 30 into this same cost function. Whatever we get for the two, we take the difference between the two and we get the exact cost of producing the 31st manipulator. Remember, if we were to look at this just a rough 30s, realize when we take 30 from 130, when we take 30 from 31, we are getting 1, right? But that's not how we do it. You must substitute what? The unit into the exact cost and then 31 to the exact cost and then the 30 to the same exact cost. So we take the difference between the two and we get the exact cost of producing that particular one manipulator. All right. So we'll get our cost function on our calculator. So I'll go to mode and then get this off. So I'll go to mode, I'll go to complex and I'll get this off. So here I want to get this function on my calculator. I have what? 375 plus 25x. At this point, I know that you know how to point what? X. And we have what? 0.25 alpha x to the power what? To the power 2. Okay. So here I'll press my solve. I want to solve for 31. Okay. So 31, I'm getting what? I'm getting, for 31, I'm getting here to be what? 9. Okay, let me go for decimal. I'm getting here to be 909.75 minus. And when I solve for 32, what am I getting? I'm also getting 900 for that. So meaning that the difference between the two should fetch me the cost of producing 31st manipulator. There's that cost. So when I have 909.75 minus 900, what are we getting? We are getting what? We are getting 9.75. But remember, we were told that these are produced in thousands of euros. So we then multiply by what? 1,000. And what are we getting? When you multiply this by 1,000, we are getting what? We are getting 9,750. 9,750. And that should be which option? Option what? B. So let's take note of that. Let's take note of that. So let's move on to question number 31. One product firm estimates that its daily total cost function in suitable unit is. So we have this cost function and a total revenue function is 28x. Find the value of what? Is it x that maximizes the daily profit? So you have to find the value of for the output, right? That maximizes daily what profit. So at the point of maximization of profit, we are saying that our marginal cost should be equal to what? Our marginal revenue. So at the point of maximization of profit, we are saying that our marginal cost should be equal to our marginal revenue. And it's at that point that we optimize what? Our level of what? Profit. And for us to get that profit, we need to know the exact level of production that we are producing to get that profit. So at the maximization of profit, we say that the marginal cost should be equal to the marginal revenue. So for us to get the marginal cost, we differentiate the cost function for the first time. And for us to get the marginal revenue, we differentiate the revenue function for the first time. So we say that here is the same thing as what? Cost prime of x, and that should be equal to what? Revenue prime of what? X. So let's differentiate what? X cubed minus 6x squared plus 13x plus 15. So differential of x squared, what are we getting? We have what? 3x squared. Differential of 6x squared, what are we having? We are having 12x. Differential of 13x, we are getting 13. Differential of 15 is 0. So that should be equal to differential of 20. What are we getting? We are getting 28. Okay. So once you get to this stage, you will say that we have 3x squared minus 12x, and then the 28 will join the 13. What are we getting? So when you subtract that, what are we getting? So we have, let me take this off. We have 13 minus 28. We are getting 15, right? So that's going to result negative 15, and that should be equal to 0. So we take our calculator and we go to mode, we select 5, and we locate what? AS squared plus BS plus C. So here we go. So I have here the coefficient of x squared to be 3, the coefficient of what? X is what? Negative 12, and then that of constants is what? Negative 15. Sorry. Negative 15. So we have our x1 to be equal to -1 and our x2 or another x to be equal to what? 5. But we know that the coefficient of x in the cost function and even the revenue function is greater than 0. So therefore, we'll say that x should be equal to what? 5. So at the production level of 5, we're able to maximize our daily profit where the marginal cost is equal to marginal revenue. So we therefore say that the output for the value of the output where we maximize daily profit should be equal to what? 5. And that should result to option D. So let's take note of that. Now, question number 32. A manufacturing company finds that the daily cost of producing S item of product is given by, so we have the daily cost here, which is what? C of X to be equal to 21X. That's 210X plus 7,000. If each item is sold for, so we have the selling price. Selling price of X is what? So given in value as 350, we are asked to find the minimum number. We are asked to find the minimum number that must be produced and sold daily to ensure no loss. So here we are thinking about what? Our level that we can break even. We are thinking at the level that we can break even. So how do you break even from this concept? So we therefore say that at the point of break even, our total revenue should be equal to our total cost. And we know that the item that we are producing in X of what? Quantity, right? X of what? Quantity or S of item. So if we know our cost function to be equal to 210X plus 7,000, then we can also find our total revenue since we know the selling price per each item, right? So therefore, we say that our total revenue of X should be equal to selling price of 1 multiplying with the total level of output that we produce as a business, right? So what are we getting? We know the selling price per item is what? 350, and then multiplying the level of production to be X, right? So therefore, we know that our revenue function should be equal to 350 what? X. So we are saying that at a point where we neither make a loss or a profit, we will say that our total cost is equal to our total revenue. That is a break-even direction that we are moving. So we therefore say that therefore our total revenue should be equal to our total cost. All right. So total revenue was for 350X, and that should be equal to our total cost of 210X plus 7,000. So here I want to find X, right? So we'll say that 350X minus 210X should be equal to what? 7,000. So what are we getting as a difference? What are we getting as? We are getting what? 140X, and that should be equal to 7,000. So here we divide both sides by 140. Here we divide both sides by 140. What are we getting as X? So when you divide both sides by 140, you should be able to get X to be equal to what? 50. X to be equal to 50. So let's take note of that. Let's take note of that. So if X equals 50, that is fine. So meaning that the number or the minimum number of X product that we are producing and so to ensure no loss is what? 50. So let's take note of that. Question number 33. If the selling price is increased by 35 per piece, what will be the break-even point? So here you see the break-even coming in here, right? So now we have increased the selling price by 35. So meaning that our revenue function is going to change, right? So of course the selling price per piece has been increased, right? So we therefore say that our new selling price should be equal to 350 plus the increase, and that should account for a rise of 385. So therefore our new revenue function should be equal to what? 385x. So once you're able to get this, then we can, at this point, we can break even, right? Can break even. Is that okay? So here we'll therefore say that what will be the break even point? We know that for us to measure our break even point, it should be what? The fixed cost, right? The fixed cost divided by the selling price per unit minus the variable cost per unit. So even with from the cost function here, we can easily get our fixed cost and then that of what? Our variable cost. Remember, we said that total cost consists of what? A variable cost plus what? A fixed cost. Okay. So how do you identify a variable cost? How do you identify a fixed cost? So always the variable cost is the cost to whom that we have what? The number of items we are producing attached to it. If let's say this X, the X will multiply that value. If it is Y, then multiply that value. If any value, you get that. So here we can say that our total cost here, function here, should be equal to 210x plus what? 7,000. So meaning that here we can see that the variable cost is what? 210x plus the fixed cost of 7,000. We can do this comparison. So in effect, we know the variable cost per each item of x is what? 210, and the fixed cost is what? 7,000, right? So if that is the case, therefore we will say that our break-even point in unit, that's what we are asked to find, right? That's in unit of x. In unit of x should be equal to our fixed cost divided by our selling price minus our variable cost per unit, right? So what is our fixed cost here? Our fixed cost 7,000 divided by the selling price. Remember here, there was an increase in the selling price per item. So that will also result to what? 385. So we have our new selling price to be 385. And then our variable cost to be what? 210. So what are we getting? We take our calculator. We switch to our normal mode. So we have here to be what? 7,000 divided by 385 minus 210. What are we getting? We are getting our break-even point to what? 40. So this is what we are getting when the price increased by 35. At the price of 35, we break even at what? 40. At the price of what? 250, we break even at 50, right? So we are getting what? 40. So let's take note of that. Then question 34. If the demand function P is equal to 120 minus 3Q, where P denotes the price of a good and Q denotes the quantity demanded, find the value of the marginal revenue at Q to be equal to what? At Q to be equal to what? 10. So we have the demand function, right? Where P denotes the price of the good. So here is the price of the good. So we also know that the quantity is represented as what? Q. So therefore, for us to find our total quantity, here's what we're going to do. We will say that our total revenue, right? Our total revenue should be equal to, so total revenue function should be equal to, here was in Q, right? That should be equal to the price per what? The quantity, then multiplied by the quantity that we are producing. Okay, we know that the price is what? 120 minus 3Q multiplying what the quantity that we produce as what? Q. That will fetch us our total revenue, right? So if that is so, then we are going to say that the Q will expand this what? Price, right? So we are getting what? 120Q minus what? 3Q square. So this becomes our total revenue function. So for us to get our marginal revenue, we will say that we will differentiate the function for the first time, right? So once we are differentiating the function for the first time, we will say that our marginal revenue, which is equal to what? The total revenue prime of Q should be equal to, so 120Q differentiated should be result to what? 120. The negative 3Q squared should result to what? 6Q. Okay, but we are asked to find what? The marginal revenue at Q is equal to 10. So at Q is equal to 10, what will be our marginal revenue? Our marginal revenue should be equal to 120 minus 6 into bracket 10 here. So we are getting here to 120, we are getting here to be 60. So what are we getting? Oh, when you subtract 60 from 120, we are getting what? 60. So meaning that at the marginal revenue where we have Q to be equal to 10, we are getting what? Our marginal revenue to be what? 60 in that line. So let's take note of that. So here, the final answer should result to what? C. And that is how we actually answer some particular question in relation to this key question that we need to know in relation to our exam. So thank you once again for watching this video. It was really helpful to you. Please go ahead to smash the like button of the video, subscribe to the channel, and then share. So I'll see you next session where we discuss other issue. Bye bye.